Welcome to the Straight from the Heart podcast, a show by the makers of Oritis about some stories and unconventional wisdom from Team Oritis, which helps you to work and run your business in a better way. Our today's topic is research toward power quality enhancement for future generation smart grid. For this, we have our distinguished speaker, Dr. Santanu Kumar Dash, PhD from NIT Rourkela, currently working as assistant professor in Vienna Vignana Jyoti Institute of Engineering and Technology, Hyderabad, India. Welcome, Shantanu, to our Straight from the Heart podcast.
Thank you very much.
We are highly obliged and privileged that you came to our podcast.
My pleasure.
So, advancement of technology in the 21st century has shown a platform to transform the conventional power grid toward advanced grid. So, what is future generation smart grid as per electronic and electrical engineering research context?
Yes, actually that is a wonderful concept this smart grid has come of in various. Actually, I have been working in this domain from last 7 to 8 years. And there is a general term we always use, that there is a demand and supply chain. It should be balanced. Without that balancing of the demand and supply chain, everything will be spoiled. So we have to, every time we have to think of how to regulate the balancing of the demand and supply chain. Like the same concept can be incorporated to this smart grid also. As this present power grid has, it is very much conventional, and nowadays the non-conventional energy sources are booming off. Because why? Because of the conventional energy sources are depleting, in the depletion they are now. So therefore, we have to use the renewable energy power sources in our present grid. We have to integrate them to that. So that shows a platform for it reduces the cost also, and also provides the platform for the researcher how efficiently we can integrate them. So in this concept, we can use we can see that in various perspectives. The first perspective, we can see that only the integration of the renewable energy sources to the power grid. And another perspective is that how our home, one simple home, becomes very smart when there is a rooftop solar panel is there, one hybrid electric vehicle is there. In this context, the rooftop solar panel is giving the power, it's generating the power, and in the electric vehicle it is being stored, and whenever it is required, and it is being used in the home. And it is another perspective. And any other perspective also, we can see that when there is a excess amount of power generation from a smart home, from its own power supply from the rooftop, it can be also feed to the grid. So therefore, all these process cannot happen in a simple way. Various data communication, various information transfer, information gathering, all these things can be happen. So these things can happen only through various intelligence, we can say artificial intelligence, and also the involvement of Internet of Things. So which makes the total, this conventional grid is act like a smart grid. So this is in the view of our electrical and electronics engineer perspective, and this gives a big platform for enhancing the research. This is in my point of view.
Yes, Shantanu, you are right. So there is many things such as charging station and smart storage play a role in smart grid. So what is the role of power quality in the future generation smart grid?
Actually, what happens when all those things are happening in the smart grid, the one important thing come up here is the consumer electronics. In the demand side, I'm saying about the demand side. how the consumer electronics is behaving to the power. Of course, there is a generation point is there, and it is supplying to the consumers, to the demand side. But if there is this power quality will be not maintained, then this consumer side electronics, it may be a household loads, it may be household appliances, it may be industrial load, that there is a chance of damage without maintaining this power quality. So therefore, in this power quality view, we can say that there are various points are there. This power quality is classified in various category also. It may be a voltage sax, voltage swell, it may be an interruption also, or it may be any type of noise also it can be added there. So therefore, to regulate that, the IEEE has standardized the power quality by various standard manners. We can say it has already named that, like IEEE 519 standard, IEEE 1159 standard, like that. So IEEE, it has standardized that one with these names, so that people or the researcher will follow that and come up with idea which gives the result which will show the output in this standard area only.
So, as you said, there is lots of problem related to the power quality, which result in failure of customer equipment. How can the power quality be maintained in the distribution system or lines of smart grid?
Exactly. I have already mentioned about the various type of standard that is coined by the IEEE, and to regulate that this power quality with the area of by utilizing this standard only. So therefore, how we can do that? How we can standardize and how we can use this standard to maintain the power quality? Therefore, the researchers have came up with many solutions, and these solutions are it can be say that we can say that one is the power electronics devices, that is custom power devices, and the power quality conditioner, which is utilized at the point of common coupling. This point of common coupling is a point where these power conditioners or the custom power devices are attached to the distribution line, and it maintains the power quality by a certain procedure, and the customer or the demand side will get the regulated and desired power quality according to the IEEE standards only, so that there will be no abnormality will be there in the customer side, and all the consumer electronics will be safe.
Okay. As many times there is occur of problems in voltage sensitive loads due to the power quality issue. How to protect the voltage sensitive loads from the power quality issue?
Absolutely. This is a very recent research actually. I have already worked on that in this area. So before I start about this one, I can say what is this voltage sensitive load? How a layman will understand about this voltage sensitive load? I will take in one certain example. There are many sensitive loads are present in the hospital or the medical institution. Everybody knows that. So yes, during the treatment, if any type of power disturbance will be going on at the time of treatment in the medical institution or the hospitals, then there is a chance of life risk. Yes, definitely. So we have to anyhow provide any type of solution to that. That is one example. Another example is that suppose there is a financial institution or a bank, we can say, a simple example, a bank, and there is a power loss is there or power fluctuation is there. Now the banker on the financial, this medical and the financial institution, they are using the generators for power failures. But suppose there is any disturbance in the voltage quality, then there is a chance of data loss in the financial institution. So if data loss, then there is a direct impact on the human, that is money loss is there. So we have to anyhow protect that one. So to protect that one, I have recently researched about that one, and one new topology of the power conditioner has been developed in this research, that is called as the PV-Open-UPQC, which is known as photovoltaic tied open unified power conditioner. It is a very special type of power conditioner which protects specifically the uh, voltage sensitive loads. It is connected at the point of common coupling before the voltage sensitive loads, and it provides a protection towards that. And in this my research also I can say that in this and I have already mentioned that renewable power is also integrated through the to the smart grid, and this topology has also a very much good feature that it also integrates the photovoltaic renewable power generation system to the grid. So this is my recent research.
Okay. You said about the power conditioner, right?
Right.
So what are the procedure power conditioner work and regulate the power quality?
Power conditioner, it is actually power electronics device. Actually, this I have already told that this device is required to be installed at the point of common coupling before the sensitive loads, and it is in the concept of the voltage sensitive loads. And these power conditioners can also be supply the power quality or can help to regulate the power quality in two ways. That can be a current quality problems and maybe the voltage quality problems. So these two things can be tackled by these power conditioners. And actually, how we can do that? That is a very good research area, as presently many of the researchers are working in this domain. And I have also worked in this domain. And I can say that to regulate or to make the power conditioner work, we have to sense the different type of disturbances present in the part of voltage sensitive load. We have to sense that first. So after sensing that, we have to feed them to a embedded processor. And what is the work of this embedded processor? In this embedded processor, we have a certain algorithm, and this algorithm plays a vital role to regulate regulate the power quality, and it will provide a path to the sensed information of the disturbed voltage signals or current signal. It may be also, it will provide a path, and through that path, through this algorithm path only, it will follow certain steps, and it provides the output to the power conditioner, and this output is called as the switching signals. And this switching signal helps the power conditioner to work, and it provides the compensating signal at the point of common coupling where the power conditioner is installed. And after injecting the compensating signal to the point of common coupling, the disturbances get cancelled. So after that, this power quality is maintained as per the requirement, as per the IEEE standards, whether it may be IEEE 519 or it may be IEEE 1159 also. There are also many other standards are there, but I am specific in these two standards because I have recently worked in this using this standard only. And also this algorithm, what I am already discussed about, which may be installed or which may be used in the embedded processor, and this algorithm, this must be in suitable adaptive algorithm. It may be a simple algorithm also. Previously, simple algorithms are being used, but as the technology is going very fast, it is advancing day by day. So that's why, and disturbances also Also, we can see very much many disturbances are coming off at the time of demand side or in the side of supply side also. Therefore, our algorithm must be an adaptive one. So this adaptive algorithm will take care of any type of disturbances it will come. It will take care of that one. It may be a voltage type of voltage disturbances, or it may be a current type of disturbances also. So in this part, it will take care of the voltage sensitive load also. Their focused in this research has been given to the voltage sensitive load through this adaptive controller. So therefore, this is actually new topology which is called as PV-Fed Open Unified Power Conditioner, Open-UPQC. This is a new topology actually. It is proposed by my research.
Okay. So that's all for now, Shantanu. Thank you, Shantanu, for taking some time for us and tell us about this great thing.
Thank you very much.
Stay tuned for further more episodes. We will come back again with more such personalities and share their knowledge and experiences. For our episodes, you can subscribe us in Google Podcasts, Spotify, and Anchor.